Hi, my name is Vineet and I'm going to show you how to take advantage of counters and digital I/O lines on a data acquisition device. Right here I've got an M-series USB data acquisition device. This is actually cabled directly to this BNC terminal block. This is a connector block called the BNC 2120, and it basically gives me access to my I/O lines through BNC connectivity or screw terminal. And there's a few other things on here like a function generator and even some LEDs that I can use to monitor a digital line. If we switch back to LabVIEW, you can see that I've basically started with a blank virtual instrument or a blank VI, and I can click on the block diagram and drop down the data acquisition assistant. From here I can select all the different types of I/O that are available to me on this data acquisition device, and because in this case I want to take a counter measurement, I'm going to go to Acquire Signals and Counter Input. Now you can see all the different tasks that are available to me with a counter. Counters are some of the most versatile functions on a data acquisition device, and everything from counting simple edges to frequency measurements to generating pulse width modulated signals and even connecting to an encoder and reading position information. Well, in this case we're going to keep things simple and just choose an edge count. I'm going to select counter 0 because that's the one that I'd like to measure in this situation. And if we look at this BNC connector block, you can see I've already wired up from one screw terminal into counter 0. And in fact, I've got that connected to this dial here, which is going to generate square waves or pulses every time I spin it. This way I can count the rising edges that are coming from this terminal on counter 0. If I look at this DAC assistant here, I can actually configure my counter, and I can even test the connections by hitting run up here. And now if you watch in software, in this measured value square, I can generate pulses and actually see those rising here. So I know my connections are correct, and I know that I'm ready to go with my data acquisition task. I'm going to click OK, and it'd be nice to be able to see that count register somehow in hardware. So let's go ahead and drop down a second data acquisition assistant in order to read the counter value and then write out the register value using our digital lines. I'm going to drop down a second data acquisition assistant here. In this case, I'm going to choose to generate signals. I'm going to go to digital output and choose port output. That way I can write to 8 lines at a time. I'm going to choose port 0. And in this case, I can in fact even test out the digital lines here. When I hit run, I can toggle different values of my LEDs, and I can see the corresponding LEDs on this BNC connector block. So I know that I'm connected correctly. Now I can hit OK, and all I have left to do is to simply wire from my counter output to my digital output, or rather my counter input to my digital output. Once I've done that, I can hit run, and now I should be able to see the corresponding count register on the LEDs that are being displayed. So as I spin the dial, you can actually see this happening right here in hardware, and the LEDs are corresponding to what that current count is. So that's how you can take advantage of counters using data acquisition devices and LabVIEW.